Welcome to StrategyGrid.ai learning series. In today's fast-evolving AI landscape, professionals are increasingly relying on intelligent tools to support decision-making, research, and innovation. But alongside these opportunities comes a critical challenge: AI hallucination, where systems generate confident yet incorrect information. In this session, Managing AI Hallucination, we provide a guide for professionals so that they can be able to explore what hallucinations are, why they occur, and the practical strategies to detect, manage, and minimize their impact in real-world professional settings. AI hallucination occurs when an AI system generates inaccurate, fabricated, inconsistent, or misleading information and presents it with high confidence as if it were factual, even though it is not supported by the input data, training data, or external evidence. Importantly, this is not a software bug. It is a natural consequence of how probabilistic AI models work. These systems do not reason about truth. They predict the most likely next word based on patterns in data. So they optimize for probability, not accuracy. Research has shown that hallucination rates vary widely depending on the task. For complex or ungrounded tasks, error rates can exceed 50% and in extreme cases approach 90% or more. The real risk isn't simply that AI makes mistakes. Humans make mistakes too. The risk is how convincingly AI makes mistakes. Common examples include fake citations or studies that don't exist, confident but inaccurate statistics, invented websites or sources, biased or distorted outputs, and occasional reproduction of sensitive or confidential data. This leads to what I call the plausibility trap. If it looks right and sounds right and is formatted right, we assume it is right. That assumption is where the danger lies. So today, the question is not should we use AI? That debate is over. The value of AI is too significant to ignore. What we are asking is, how do we use AI safely when hallucinations are guaranteed? And the simple answer to this is strategic placement of humans in the decision chain. Here we see several examples of how AI hallucinations are already affecting real-world practice. For example, a chatbot provided incorrect travel advice and the organization was held accountable. Also, there are reports of AI tools producing misleading outputs in coding and consulting environments. We have also seen legal professionals submitting fabricated cases generated by AI. And now there is explicit warning against using AI without verification from courts. Together, these cases highlight the practical risks of AI hallucinations across industries. To manage AI hallucinations, we need a practical anti-hallucination framework built on a simple risk-based rule. Where must a human verify before we act? The key idea is that hallucination rates don't suddenly disappear. What changes is whether humans catch them before harm occurs. So the higher the consequence of being wrong, the closer the human oversight must be. This leads to three operating modes. The first is human in the loop, where a person approves each output and verifies facts before use. This is essential in high-risk contexts like healthcare, legal, and financial decisions. The second is human on the loop, where humans monitor patterns, review exceptions, and audit AI behavior. This works well for operational or analytical systems. And finally, human out of the loop, where AI operates autonomously and organizations knowingly accept hallucination risks, typically in low stakes cases. Next, we'll look at each of these different components in detail. Human in the loop is the strongest safeguard against AI hallucination. Here, AI generates drafts, analysis, or recommendations, but a human reviews before anything is used. That review involves fact checking, validating, sense checking, and editing. Then comes a decision gate where the human can approve, revise, or reject the output before it becomes a report, communication, or decision. This approach is especially important when AI outputs affect decisions, money, people's rights or safety, public trust, or professional reputation. Typical examples include contracts, financial reports, policy documents, stakeholder communication, and regulatory submissions. The goal is simple: catch AI errors before they cause any harm. Next is human on the loop, which is a lighter oversight model where AI runs continuously but humans supervise performance rather than checking every output. The system operates autonomously while dashboards and alerts provide live monitoring. Humans step in only when thresholds are breached. For example, unusual patterns are observed, errors are flagged, or risk indicators are portrayed. At that point, a human can override the system by adjusting, pausing, or escalating the issue. This works well in operational environments where reviewing every output will be inefficient, but oversight is still necessary to manage risks. The key idea is simple. Humans monitor behavior and intervene when something goes wrong, rather than reviewing every individual AI output. Lastly, is human out of the loop, which is where AI operates without meaningful human verification. The system generates outputs and they are used directly, which means any hallucination may go undetected. This approach is only appropriate when operating in a low risk context where errors are cosmetic, easily reversible, non binding, and typically for internal use rather than public or client facing context. Common examples include grammar checking, spam filtering, meeting transcriptions, brainstorming support, or generating drafts. In such contexts, mistakes are inconvenient but not harmful. The key message is that human out of the loop is not unsafe by default, but it requires careful selection of low stakes use cases where hallucination risk is acceptable. After going through all the three approaches in the framework, a key takeaway is that AI hallucination risk varies by use case, from very high in legal, medical, and financial contexts to much lower in creative and ideation tasks. The implication is straightforward. The level of human oversight should match the risk of being wrong. Responsible AI use is therefore not about avoiding AI, but about using the right oversight model for the right task. And that is the core message. Trust AI for speed and capability, but trust humans for accountability and judgment.